Yeah, what you're going to be looking at in this video is function. We have been using function from the beginning of this program where we try to output a string or an integer to the screen, and also we have been using function where we try to check for the type of um, any value that we put inside the type function. So a function is a name sequence of statements that perform a computation. When you define a function, you specify the name and sequence of the statement, and then to use that function we invoke the function by calling the function by its name. So calling a function, like I said earlier, we have been using some function here which we use in checking for the type of an integer or type of a string or type of any value, which we return an object here saying class that this integer value is an integer. This value passed into this type function is an integer. So that is an example of function, a computation that does something in particular when it has any input or without any input. Any function that have input, and that input we call it an argument. We call it argument. So the name of the function here is type, then the expression in parentheses is called the argument. This is the value that is being passed into the function in order to compute for any value that we have in that function. So the result of this function is the type of the argument. So here, this function here will define the type of whatever value you put in, and it will return the type, which is the return class that we have here, class integer. So that is an example of function that we have been using so far. It is common to say that function takes an argument and return a result. The result is also called the return value. Here, this function type take an argument. Likewise, function print also take an argument, what you are trying to print to the prompt. And also we also have return value for functions, the value that is being returned when you call a function, such as the class here, class integer. So Python provide functions that convert value from one type to the other. Here I have a string of 32, and if I check for the type of 32 in quotes, it will return string, but I can convert that into integer by using the int function to convert this into an integer. So we can take a look at what we have in our code here to see how that works. So here I create a new file. I'll call it function func dot py. Then inside this func dot py I will have a variable. I will say num, then I will use it I will give it a string value of 54. Then this num here will be holding the value of 54. If I should try to check for the type of num, it will return 50 string here. So I can just print out the result from here by putting it in a print function here. So this print function will return the value that this type num is going to be returning to me. So I save my file and I call the function from my prompt here. I will be having the function name. I will call it by saying Python, then the file name func.py, then I call it using that name. It will return the class of the value that is being passed in, which is trying to tell me that the return class for the type num is string. Then I'm using the print function to print it out to the prompt here. Here this type num is returning a string value, which is indicating that this is the return value of this type function. If I don't want to print it out and I just want something like, okay, just give me the type, then I comment out this code that I have here by using the hash symbol. I save my file. Here we won't be having any output because I'm not outputting anything to the console. So what I'm just trying to do on this line 3 is that I'm using the print function to bring this return value to the prompt here as my output and not a return value. So that is about uh, return value in function that we can have. And we also have other conversion function here. I have my num here to be holding a string value, which is a string here, 54. 54 is a string and not a number. So I can also convert the type by commenting this and also bringing type converting it on the other line by saying, okay, this string I want to convert it to an integer by saying int, this int function. Then I'll put that variable that is holding the value of this string inside the int function to convert whatever this num is holding into an integer. It will try to convert it into an integer. So this num in this int function is known as an argument. Then I can also use the print function to print out the type of this value. So I can say the type of num on this other line. Now the type of num, it will also print it out. And as we know, when we are dealing with scripts mode, whatever we are trying to output will be outputted by giving the interpreter the opportunity to read our code line by line. So this interpreter will read our first line by, okay, creating a variable and populating it with the value 54, then giving it using this type function to get the type of that variable and printing out the type. Here also I can also say, okay, I'm using this function int to convert the type of this variable num into an integer. Then I'm outputting it using the print function again. So the print function don't have any return value, it's just outputting something to the screen, whereas the type function has a return value without outputting anything to the screen. As we have seen earlier, when I comment my print function out here and only have my type num, it doesn't print anything to the screen, but it has a return value. So I save my file and come here to run the program again. We should see the effect now. Now I'm printing the class string, and also here I'm printing the class string. So here what this is trying to do is, why there is an error here is that here I am converting num to an integer. So I can also do that by saying, okay, print out the type. Then I'm saying, okay, this type I want to convert this function here int to a num. So I'm printing out num. I'm printing out while converting this num into an integer. Then I'm checking for the type, then that return value will be printed out using this print function. So yeah, I am also already having a nested function that we can work with also here, which means a function can also have different kind of expression as the argument. Here the print function has its own argument, which is an expression. This expression is a function that also has its own argument. The function type has its own argument, and this argument again, which is an expression, also has its own argument num. So num is being checked, the value for num is being checked, converted to integer. Then this return value, when I convert to integer, will be passed to the type variable, then the type function. Then the type function will have to return another value to the print function here. So I save my file and I come back here to run my program again. Now I'm having the class string, which is for this first print function. It prints out the type of this num. Num is holding a string value here because it's in quotes. It's printing out the type. Then on this line here, I'm saying, okay, instead of printing out just the type of num, print out while converting the type of num to integer. Then when I print it out, it's now telling me that this print statement return class integer, which means this is actually working. The int function is used to convert any it will try to convert any value being passed to it into an integer. That is what the print function, the int function does. That is only when it's trying to do that. But if I have another variable such as my name, and I just say, okay, this is my name here, and I just want to output this to the screen, I'll just say, what is the type of my name? Then it will not print out anything to the screen. It will only bring out a return value without me seeing any visual effect. Then I can just print the type of my name to the screen by saying, okay, just print out my name type, then print, then I close the parentheses. So this one is going to be printing my name to the screen. I save my file and I come down here to run the program again. So now it is printing my name to be string value here. And What I can now try to do here again is that, okay, I want to try to use the print function while use instead of checking the type of my name variable here. I want to say, okay, type of trying to convert anything that I have into an integer, which is my name variable. I'm trying to convert my name into an integer using the int function. Then the return value will be sent to the type function. After that, the type function will be sending its return value to the print function to output it to the screen. So I save my file, then I come down here to check for this value here. So it return the first print statement, which is printing out this type num here. Then the second print statement, which is printing out this when it converts this num to an integer. Then the third statement say, okay, it's printing the class string for print type of my name, which is a string, and it's now return an error saying, okay, we have an error, a problem here, which is what, in this file func.py line 8, which is on this line, there's an error that happened there. It says print type int name. It says value error, which means the value that I pass into this function int is not the value it is expecting. Invalid literal for int with base 10, because this int function is trying to convert it into a number in base 10, and it cannot convert salami because this salami is a string value. It was able to convert 54 by just removing the quotes surrounding it into an integer, which makes it to be possible, but as a character or a series of character which is a string, it cannot be converted into an integer. That is why it returns an error, which is what, value error. So now let's look at what we have here. I'll try to clear my screen here. Then let's look at what we have in our material. When we try to convert the type of any other value, such as a floating point value, it will convert it by returning only the integer part without approximating the decimal part of the value. As we can see here, if I have int 3.999, even though it's only needed 0.0001 to make it up to 4, it won't be approximating, it will only be returning the integer part. And also int here, we also return only the integer part and ignoring the other one after the decimal point. So float here, we will convert any integer value into a floating point number. Here it says string, but not strings like name, like the word hello that we have here, because hello is a series of character which cannot be converted into an integer. So the kind of string it is talking about is strings such as 32 in quotes. So if I use the float function to convert it, it will also convert it to float, as we have here. When I use float 32, it bring out 32.0. Then float this, it will still return the same float since it is a float, but here it is an integer, it is a string value, so it is being converted into a float value by removing the quote, which make it possible. So let's look at what we have next. We also have the string convert its argument to a string. This string function, it converts any argument that is being passed to it into a string by just putting quote on both sides. And it also return the string function of this value that is here by putting quotes around it. So this number here are no longer float, and this one is no longer an integer because it is being converted into string by putting this quote around it using the string function. So that is about simple function that we have come across with. Next that we should look at is the functions that are already available, more functions that are already available for us to use in Python, like the mass function. So Python has mass module that provide most of the familiar mathematical function. So what do we mean by a module? A module is a file that contains a collection of related functions, such as if I have this file here, I have comments.py here. If I have any function that is being defined here and I'm trying to use that function in another file, I will just have to import it into this place without having to rewrite everything that I have written in the comment file. So this file in this case now will now be a module to this file, which means I have a module here and series of functions are being defined here. Then the functions can be utilized in another file. So this makes it a module. Now moving back to our notes, it says before we can use the function in a module, we have to import it with an import statement, such as import math. So now let us go into our file here. Then I can say okay, what I want to work with is math, but I have to make sure that I'm not using the module name to name my file, because it will return an error, which means just the same rule applicable to variable. When you're naming your function or you're naming your file, you should ensure that it doesn't have anything like that as keyword that are reserved uh, for Python usage. So now I'll just say maths.py. What I'm doing here is using maths and not math, math. I'm putting s, additional s in it, because maths module here is just math, whereas I save mine as maths, which will not create a conflict between those two files. But I have to be very very careful while I'm utilizing these functions. So now the next thing to do is to check for my maths functions that are available for consumption. When I use the import statement to bring out this maths module, like I said, it's a name of a file which is being used. But when I'm trying to import, I'd not put the .py file as an extension to that. I only use the file name, that is the module. That's how to import a module in Python. So I just say math. This is the module name, import math. Then that is the module there, and I can utilize various functions that this module provide. The name of the file initially is math.py, but since I'm importing it as a module, I'm trying to consume it. I'm not going to be putting the file extension to it. So I go back to our notes here. Let's look at some things here. It says this statement creates a module object named math. If you display the module object, you will get some information about it. So if I want to check for anything that I have in my math module, I can just put this math. I can just put the name math inside my interpreter, and it will surely return whatever object that it has or information that I can get from it. So this will take me back to my interpreter. Let's work with that in my interpreter here. So I can have my math function. So yeah, I'll just try to activate my shell. I'll try to activate my shell by saying Python. So now my interpreter will be available for me to use that. Then I use the import statement to import the math module. No problem. Then I can now say okay, I want to check whatever function or method that is available for me for consumption in the math module. So by clicking enter, those functions are brought to me. Then I can now look at what I have here. It says module math built-in. This is a built-in function for me to use. So if this is a built-in function for me to use, then I can also check for something by saying import maths, which is the program that I designed myself by using this file name maths here. But I didn't use the file extension.py, so I can go back here and say okay, import math. Then I say oh, I want to check what I have in my maths. Then it says it is this module name is math from this user by giving the location of this file on my system. So here it's user defined, whereas what I have here as my math function is built-in function provided by Python itself. So now going back to our notes, it says the module object contains the function and variable defined in the module. To access one of the function, you have to specify the name of the module and the name of the function separated by dots, also known as a period. So we call that dot notation when I want to try to get a value from a module or function that is being provided by any module. So now this math dot log 10 is going to check for the log 10 of whatever value that we have stored in our ratio variable. So yeah, I have this math function, this math module that has this function called log10 that is taking the value of anything that is being passed as an argument into it by computing and getting the value that we have as log10 of that value stored in the ratio variable, then multiply by 10 is called the decibel. So that is about built-in function in Python. If you want to check for any function that is built in inside the module, then you use this dot notation. Then we have other method or function that are available for consumption in the mass modules also, such as the sign of any value that we are trying to find. There's also another function available for our consumption by using the math.py function to get the pi value of in mathematics that we can use in finding the area of or circumference of a circle. So to do that, I can just go into my code here by saying, okay, what I want to do here actually is to check for the value of a circumference of a circle. So what I will do here is now to define a function that I can use in um, checking for the pi circumference of a circle. That can be easily done if I just know the value for my pi, which is 3 points, which is a float number, but I don't want to do it myself. I want to get that pi value from Python itself. I can get it by using math.py. Okay, let's check in interpreter here. We still have this math module being installed. I can just say math.py. Let's see the return value. It returned 3.14415. This is the pi value that is being returned by the math function. So I can just copy this float value and store it in my variable pi, or I can also use the math.py function in running my program by giving the program the ability to call the math.py at every time it needs it. So without wasting much of our time, because right now I won't be diving into user defined function, let us look at some additional functions that are available for us in the math module. Here we can also get the sign. Like I said earlier, we can consume the pi, and the expression math.py get the variable pi from the math module. Its value is a floating point approximation of pi accurately to 15 digits. So yeah, I can also get the square root of a number by using the math.square root. Then let's check that out. I can say math.square root sqrt. As you can see, sqrt, then I put in the value that I want to get. I know that the square root of 4 is 2, so it will return a float saying, okay, the square root is going to return 2.0. I don't want to get anything like float value. I want to get an integer value, so that value can also be converted into an integer by saying, okay, whatever value you are going to be returning, I want you to be in an integer form. I'm trying to convert it into an integer. Then what am I trying to convert into an integer? The return value of math dot square root of what? Math dot square root of 4. Then this will be returned to me in integer form, which is just 2 and not 2.0. So that is the functions that are available for us to consume a Python, which is called the built-in functions that are available, not user defined. If it is user defined, like we have seen above here, it will be return the location of this file as the root of the file, but here it is built in into Python. So now let's go back into our notes and see what we have next. Composition. Yeah, like I have said earlier, um we can work with various expression inside the function, like we have seen in our recent file here that we have here, which is func.py here. I have various expression inside this print function, which is I have a function that have another function as an argument. To check for the value of that function, convert it to int, then check for the type, then print out the type of that value that is being converted into an integer using the print function. So this function have several computations to do. The print function will first compute what is inside these parentheses. Then what is inside this parentheses is also a function which will first compute what it has in the parentheses. What it has in the parentheses also has something to check. So that is how program flow works, from outside inside, or from top to the bottom, as Python will read our code. So let's go back to our notes. Here it says, so far so good. We have looked at elements of a program, variable, expression, and statement in isolation without taking how to combine them. So we can combine all this by saying, okay, the variable degrees divided by 360.0, then multiply by 2, then multiply by math.pi. Then that expression, the expression here, the value, the result that I'll be getting from this computation will be sent to this math.sign function. Then this math.sign function will return its value. And I can also call another function, this exponential function, by saying, okay, math.log, you should find the log of this, then return it into math.exp. So I can just do anything that I actually want to do. And to be sure of what I'm doing, when I'm naming a variable, the variable name, then followed by an assignment operator, which is equal to here, then I have whatever value I'm trying to pass into that variable name. The value I'm trying to pass will be computed, then it will be entered into the variable name, and not the other way around, like saying hours times 60. This one is very wrong, why this is the right way to do it, which will return syntax error. So now let us look at user defined function in the next video. Thank you.